Welcome back. In this video, we're going to close out immunization. There's no mini exercise associated with this video. We've been working on this April 2nd duration and immunization spreadsheet. And the idea is we've got some hypothetical liability stream, pretty simple. It's just one cash flow, right? And then we've created a portfolio of bonds to cover that liability stream. And right now we've got a portfolio of one bond with about the same market value as what the liabilities are worth today. The problem is, if interest rates rise, the discount rate on the liabilities rises, the yield to maturity on all the bonds rises, and now because the bond portfolio has more interest rate risk, now our portfolio of bonds is no longer sufficient to cover the future liability stream. So here's where immunization comes in, right? Designed to minimize interest rate risk. And here's what we need to do, right? Create a portfolio of assets, the bonds, so that the value of the assets, the market value, is equal to the present value of the liabilities. And then we also want to match the modified durations or the dollar durations. Both of those things do the same thing. And let's see how to do that in Excel. As you can imagine, it involves using Solver. And so what we want to do is, given the architecture of this spreadsheet, we want to set the market value of the bond portfolio equal to the present value of the liability stream. And you can see right now this cell computes the difference between those. So set this cell equal to 0, right? And then we also want the portfolio's modified duration to be equal to the liability stream's modified duration. If these two cells are set equal to 0, then changes in interest rates, a shift in the yield curve, should keep the bond portfolio and the liability stream, have them change in value by about the same amount. So let's check that out using Solver. Okay, so there's a couple different ways to do this, and there's not a unique solution in terms of a bond portfolio here, but let's set these conditions and see what happens. So let's say that the market value of the portfolio minus the liability stream, set that cell reference. We don't want to maximize or minimize it. We want to set it to a value of 0, right? And then we'll do that by changing the amount that we invest in each bond. So changing the variable cells, these unconstrained cells, are the amount of face amount that we purchase of each of the 3 bonds. So tell Excel, play around with different bond portfolios by adjusting the amount of face amount that you purchase in each of the 3 bonds, subject to one constraint. And that constraint is going to be that the durations of the bond portfolio and the liability stream have to be the same, right? So that the difference between the portfolio modified duration and the liability modified duration, we want that to be equal to 0 as well. Let's say we can only have long positions in the bonds. We want the face amounts to be positive. I think that makes sense. And if we click solve, let's see what kind of bond portfolio we come up with. I got this. If you do it on your end, there's a good chance you'll get something else because there's different combinations of these 3 bonds that will give us a portfolio with the same market value and then also the same modified duration. But let's see what happens when we shift the yield curve now, right? Before, when we shifted the yield curve, the bond portfolio was worth about 100 some, maybe 170 some dollars less than the liability stream after interest rates rose. So let's see what happens if we increase interest rates by 100 basis points. That increases the liability discount rate and the yield to maturity on all 3 of these bonds. And you can see that after interest rates change, the bond portfolio's value is pretty close to the liability stream, much closer than the non-immunized portfolio we started with. So that's a good thing, right? We can see that the values don't stay exactly the same because duration is not an exact measure of interest rate risk. It's an approximation. If you want more details on that, we've got a correction called convexity. Feel free to get in touch if you want to learn more about that. Okay? But for now, the key to immunization is finding a portfolio where the market value of that bond portfolio is equal to what the liabilities are worth today, matching the modified durations of the bond portfolio and the liability stream. Okay, so a couple limitations of immunization. This assumes that the whole yield curve shifts by 100 basis points. In real life, that's not how it works, right? In real life, when interest rates change, maybe short-term rates change by more than long-term rates, so the yield curve either steepens or flattens, right? Or some other limitations um, is there's some other limitations. You can read up on them if you want, or we can talk more offline. And then if you're interested in some of these other alternatives to immunization, feel free to give me a shout out. Happy to spend more time on those. But I think the main thing to get you started on understanding how interest rate works and how we manage it is really with managing duration of a bond portfolio. So thanks for tuning in. The next chapter is going to be about managing default risk, another key big risk in bond investing. All right, thank you.